Greetings and welcome back to the module 7 titled Shielding and Deshielding Mechanism. The objective of the session is to understand the various factors influencing the chemical shift. At the end of the session, the learners will be able to explain the shielding and deshielding mechanism. Before going to this, let us revise the principle of NMR spectroscopy and the chemical shift again. As we all know that the spin states are degenerate in the absence of magnetic field, and the magnetic field strength of around 2.35 Tesla is applied to the nucleus, then the degeneracy is lost. If we irradiate the radio frequency radiation of 100 MHz, then the flipping of protonic spins used to take place at resonance. But not all the protons resonate at exactly 100 MHz due to the chemical shift, which we have discussed in our previous module. The origin of chemical shift in the NMR lies in the degree to which a magnetic nucleus is shielded from the applied magnetic field by the electron cloud surrounding the nucleus. Let me explain with the image which is presented in this slide. We are having two nucleus, left side bare nucleus, right side nucleus surrounded by electrons. These two nucleus will not experience the magnetic field in an exact similar way, because the nucleus surrounded by the electrons will not allow the nucleus to experience the magnetic field as it is experienced by the bare nucleus. I repeat, the bare nucleus experience more magnetic field when compared to the nucleus surrounded by the electrons. If you look upon the shielding mechanism, the more dense the electron cloud, the less effective is the magnetic field experienced by the nucleus, and thus the lower is its precessional frequency. I repeat, the more dense the electron cloud, the less effective is the magnetic field experienced by the nucleus, and thus the lower is its precessional frequency. Thus, shielding leads to a lowering of precessional frequency, that is, to a lower chemical shift value. Whereas, any influence which reduces the electron density will reduce the shielding effect on the nucleus, and the nucleus is said to be deshielded. Deshielding leads to an increase in the precessional frequency, that is, to a higher chemical shift value. Let us explain, let us learn this shielding and deshielding mechanism with an example which we have seen before, that is tertiary butyl alcohol. We are having 10 protons, as we have seen in our previous module. All the 10 protons are not resonate at 100 MHz. They are shifted to 130 Hz and 400 Hz respectively due to the chemical shift. If you see The 9 protons of the methyl is connected to the carbon. Carbon is electropositive, so it pushes the electron onto the hydrogen atom. Thereby the hydrogen is shielded. So the 9 protons of the methyl comes very close to 100 megahertz, that is shielded protons, whereas the proton connected to the oxygen is electronegative, which attracts the electron towards itself. Thereby the proton of hydroxide is deshielded. Hence, shielding arises in a proton if it is surrounded by an electronic cloud. If you remove the electronic cloud by any influence, then the proton will become deshielded. I hope you people have understood the concept of shielding and deshielding mechanism. Kindly clarify your doubts, if any, in the online session. The Google Meet link and the timetable will be shared through WhatsApp group. Thank you for your active participation.